Okay, we had a little break to change some equipment. We're back. I just want to give you an idea of finish the syllabus, and then we'll go through some things that I think you should probably be aware of before you get yourself started. Okay, we talked about SLO, Student Learning Outcomes. That's a function of the accreditation team, ACCE. So that's not really what you're worried about. Course objectives are you got to be able to use a tape and make associated corrections and do layout. You ought to be able to do leveling, vertical control. You'll be able to use the level, the laser level, set them up, be able to tie them to a rod of some sort. Traverse, we use that all the time. Traverse is just a multi-sided figure, can be as little as a triangle all the way up to a multi-sided figure. How to find interior angles, how to figure out directions, how to make sure they close, so when you get done you've got something that's got a box instead of an open figure. Horizontal and vertical curves, I'll give you an idea of why those are important. And construction layout and techniques of calculation. The book you're going to be using and should have is this guy right here. It's Construction Surveying and Layout. It's by Wesley G. Crawford. We'll be covering quite a few chapters in that text, so you will need the text. It's open book, open notes for your tests. So having that book available to you is probably going to be a definite advantage. Evaluation of work. The lab is busted into the two parts as noted before. We've got the lab session, which will be outside, the project session inside. So 2 parts, 25% for the whole lab, which is 12.5 for assignments in class, and 12.5 for the outside work and the reports. Test 1 is 25, test 2 is 25%, and the final exam for 100%. So it's basically 4 25s. Labs 25, busted into 2, the 2 tests, and the final exam. That'll make up your grade. Those should be noted that way in Canvas. You will post your grades at any point in time. All you got to do is, instead of bothering Vijay or myself, all you got to do is go to Canvas, open it up, look at the right-hand column, and that's going to tell you exactly where you're at in the class. And based on that, the next page on it tells you, let's see, where are you at? Yes, the next page tells you the percentage for the grade in the course. It's 10-point system, 90, 80, 70, 60. Anything below 60, you'll probably be back for a rerun. We've got 60 students in this class. If history repeats itself like it normally does, I would guess that 3 or 4 of you are probably going to fail the course. I don't know the names of you. I know the profile of you, but I don't know who you are. You'll tell me as time goes on. If you don't give a rat's ass and you could care less whether you learn anything, you're probably going to fail the course. And that's the way I believe it should be. So you got to put some effort into it if you want a decent grade. That's the metric. I just go to the Canvas at the end of the semester. I look at this little guy right here that says if you're between 90 and 100, you get an A. 80 to 90, you get a B. And that's what I report to the BRSAR's office. Okay, or the registrar's office. Test 1 and 2, I said we were going to have 3 test vehicles, test 1, test 2, and final exam. Test 1, we're going to cover math essentials, distance measuring, chain corrections, layout techniques, and leveling. That's chapter 12, 4, 13, 19, and 7. We'll have a break, take test 1, move on, test 2, and now, excuse me, there's laser level, angular measurements, and a little traverse. So we've got 12 is math essentials. We basically have 1, 2, 3, 4, about 4.5 chapters. And then test 2 is finished traverses, coordinate, geometry, horizontal curves, vertical curves, and quality, and a little bit of extra construction control documents, which I'll show you some real life drawings and what you need to know about easements, right-of-ways, and all that kind of stuff. Get done with that, that's test 2, and the final exam is a comprehensive. So if you know what's on test 2 and you know what's on test 1, the final exam is just a review of those. So it'll be a comprehensive exam. Then I got a schedule telling you what we're going to do. As noted in the email already sent to you, we will not be having labs the first week of class. Classes start on the 26th. We're doing this on a Thursday, which is the 20th. So a week from yesterday, classes will actually begin. 26th. Lecture and lab 1 are on Tuesday. So that's not going to happen next week. To keep us in sequence, I've elected not to have lab 2. So your first meeting with me will be this video, and that will be Tuesday of the week after. And if I've got my numbers on my list properly, you will be September 1st should be the first time that you see this video. I'll probably put it in the 31st in the evening, but so the 1st, which will be Tuesday after the first week of class. Okay, so that's basically the syllabus. You will not have a hard copy of this. You have an electronic copy. Make sure you're in sync with which section you're in. The only thing different is the dates. The section 2 is going to have a Thursday date in it. Section 1 has 2 Tuesday dates. So make sure you're dealing with the right one. We'll talk about things a little better face-to-face on Tuesday and Thursday at 11:30. We aren't going out the first week. We'll be inside. Put together all the formats, make sure the protocol's right, make sure you know where you're going, give you a preview of the equipment and that sort of thing. Okay, so that'll get us there. Okay, what is it going to take for you to be successful in this course? Well, as I mentioned, surveying is all elevations and plan view geometrics. It's all math. If you can do math, you can lay out anything. And we're going to go through the list a little bit. Math Essentials is chapter 12, so if you have a chance, go through chapter 12. Make sure that stuff isn't Greek to you. Make sure you understand what we're talking about. If you've had 1230 and you paid attention at all in high school, you ought to be in good shape. The math in this course, except for maybe one little small segment, is high school math. We don't get into anything higher than high school math. So if you think this is tough, we've got a problem with your primary and secondary education. Because our 1230 is a review of high school math. I went through a curriculum of my grandkids, actually a friend of my grandkids, and 9th grade, 10th grade, they're by what I teach in this course. And yet we have student upon student upon student who can't do the math. You picked the wrong field. You picked a STEM field. Construction is a STEM field. Science, technology, engineering, and mathematics. So if you're in it and you don't like math, you probably ought to look for something else, because it is math. Okay, things you ought to be able to know. Okay, we're going to do measurements. Measurements is one thing we're going to play with. So you got a tape. They come in different forms. They come in a carpenter's tape, which is in a little reel. They come in a chain with a 100-foot or a 200-foot chain that you wind up into a reel. They come in a stick form, which is a level rod. But they're all exactly the same thing. You can lay one on top of the other and they're all going to match all the numbers. Okay, but we do have 3 different types that you're going to be exposed to. Depending on where you work and who you work with, you're going to have an architectural tape. That's like a carpenter's tape. It comes in feet, inches, and fractions. 14 feet, 7 7/8 inches. 13 feet, 2 1/2 inches. That's an architectural. So it'll be 13 feet 2 1/2 inches. So you're going to have to be able to read the tape. We've got an engineer's tape. Engineer's tape is in feet, tenths, and hundredths. So instead of inches, you're going to see tenths. So between the red numbers on the tape, if I have 13 feet here and 14 feet over here, if I have an architectural tape, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There'll be 12, 11 little lines in between there. 1 inch, 2 inch, 3 inch, 4 inch, all the way up to 11 inches. 12 inches goes to the 14 feet. And then between those little lines, you're going to have more little lines. And those lines could be a 1/2 inch, a 1/4 inch, an 1/8 inch. And even some tapes go down to a 1/16 of an inch. So you're going to have to be able to handle that. As opposed to an engineer's tape. An engineer's tape has 1, 2, 3, 4, 5, 6, 7, 8, 9. It's going to have tenths. It's going to divide that foot into 10 parts. And if we would do that, 13.20 feet. Okay? That's the same as 13 foot 2 1/2. But it's in a different format. It's in an engineer's format. Why? Why don't you just throw one of the tapes away? Every drawing I've ever seen that's associated with architecture has got this dimensions on it. Every print I've seen associated with civil work, site work, land, roads, anything associated with site work has an engineer's tape on it. So you're going to have to go back and forth between the two tapes. The site plan is going to be in feet, tenths, and hundredths. The building sitting on the site is going to be in feet, inches, and fraction. And then, if you work abroad, you're going to have a metric tape. One of the worst things I ever experienced as a builder was getting cabinets in from Canada. They sent them to the job site. The guys had to put them in. They're looking at the things and they've got these goofy numbers. 25.3 cm. First thing they ask me, what the hell is a cm? Then how do you get, their tapes all had inches on it. How do you get from 25.3 centimeters to feet and inches? You as a project manager are going to have to figure out how to get the guys in sync. And if you happen to be bringing stuff in from overseas, they're going to be in metric. If you're working overseas, you're going to have to switch your whole thought process, and you're going to have to be dealing with in metric units instead of the foot-pound second system. So we've got 3 tapes. We're not going to use this one in class. We'll be using these 2. So you have to be able to read and write down and say what you read on a tape. So measuring. And of course, what do you do when you add them up? What happens with this? You got to be able to have the fractions. You got to be able to change units. This is a base 12 system. This is a base 10 system. When I get to 12 here, I move this one up 1. Okay? When I get to 10 here, I move that up 1. So if I have 100 in this spot here, 13.99, as soon as I go to 13.100, it's 14 feet. So you got math. You got to add fractions. You got to be able to flip fractions. You got to be able to divide fractions. So you got to have fractions. We also have something called degrees, minutes, seconds. Angular measurements. A circle is divided into 360 degrees. A degree is 1 unit, is divided into 60 minutes. A minute, 1 unit, is divided into 60 seconds. So now you've got a base 12 system here, a base 10 system here, a base 60 system here. Okay? We can either have degrees, minutes, seconds, or we can have decimal of a degree. Got to be able to go back and forth. You try to add degrees, minutes, seconds, it's harder than adding a decimal. So you got to be able to get angular measurements. Add them, do whatever you need to do to make them work properly. Okay, we've got geometric shapes. Okay, you got to be familiar with geometric shapes. Geometric shapes that we'll be dealing with, there's several of them. Simplest one is a square or rectangle. Triangle. Those are fairly common shapes that we see out in the field. Okay, rectangles, parallelograms. Got parallelograms out there. What else do I have written down here? Rectangular squares, parallelograms, triangles, circles, horizontal curve, which is a circular curve. Okay, and we've got a vertical curve, which is a parabola. Okay, so those are shapes. So you ought to know the geometry associated with those guys. Okay, associated with those guys, the geometry is also trig. So you gotta be able to handle trig. A lot of that stuff is trig. Part of it is just geometry. We'll be dealing with all of those. This is traverses and laying out buildings. A lot of buildings are square. Rectangles or triangles. If you've seen the building over, the music building over on campus, the guy who laid that out, everything he did was triangular. Okay, parallelograms. Circles, we got a lot of circles. I had students call me about laying out a circular foundation for silos. How do you lay out a circular foundation when you can't take a string and walk around in a circle? How do you do it with a transit? Parabolas, vertical curves. I'm sure you've gone underneath a viaduct or some sort, or over a road with a curve. Those are parabolas. That's what some of our spirals, we're not going to do that in this class. That particular subject I tried to teach years ago and it turned out to be a fiasco. So we'll stick with parabolas. Okay, trig, you better know how to use sine, cosine, tangent, and the Pythagorean theorem for right triangles. A squared plus b squared equals c squared. And then when we get law of cosines and law of sines.